guys. I am going to try to get Wednesdays and Thursdays notes up today. That's the goal, but this is Wednesdays. And um, it is the second to the last, and it is solving logs. Okay. So when you're solving logs, I'm going to go ahead and get rid of this because it just seems like so busy. Okay. When you're solving logs, there's a couple of tricks to it. What you need to remember is to think about this. Okay. To undo a log, you exponentiate. Okay. To undo a log, exponentiate. To undo an exponent, you take the log. This will make sense in a second, but I want you to know these words. To undo the log, you exponentiate. To undo exponent, take the log. Okay? A lot of this has to do with just manipulating it so we can use those 3 rules we learned this morning. Okay? Being able to use the log multiplication, how you multiply logs, divide logs, and bring down the exponent. That's going to prove very useful. The other cool little trick there is look, if you have the log base b of x to the whatever, let's say m, and that's equal to the log base b of x to the 4th, right? Okay, you can equate m and 4 because all of this is the same. Then m equals 4. You can also, we're also going to take advantage of when this matches, that equals 1. Okay, that's what we use to graph today. And log b of 0 equals 1, although I don't think this will happen that often. Trying to think. Well, I guess I'll handle the rules as they come. Okay, so take a look at this. I'm going to rewrite it just a little bit bigger. Okay, it says solving an equation involving logarithms on both sides, problem type 1. So before, when we had a logarithm on one side, it was really easy because you just had like log 5 of 2 equals x, and then all you had to do was rewrite it, right? And then you understood what was happening. But now we have it on both sides, and so now we got to use some trickery, if you will. Okay, so do you notice that both, well, let me rewrite it. It says if there's more than one solution, separate them with commas. If there's no solution, click on no solution. All right, so we have log 5 of x plus 8 equals 1 plus log 5 of x plus 4. Okay, do you notice how there's 2 log 5s? That's going to be really important. So what we want to do is we want to get these together, okay? The 1 complicates everything. If we had just had log 5 of x plus 8 equals log 5 of x plus 4, we could have just equated the x plus 8 and the x plus 4, but this stupid little 1 is here, so dang it anyhow. So what we're going to do is we are going to subtract log 5 from one side. Okay, we're going to get the logs on the same side. That's our trick, okay? And I'm sorry, my equals will not line up. Log 5x plus 4 equals 1. Okay, now you have a minus sign, okay? A minus sign. Oh, I forgot to do this. I always forget to do this, to knock them down, knock them off. Okay, so now you have a minus sign. So you can use, see how they're the same base? So now you can use rule 2, okay? And you're going to rewrite it. You're going to use rule 2 to rewrite, okay? So we're going to go log 5 of x plus 8 over x plus 4 equals 1. Okay, and now we're there. Now what do we do from here? Okay, so in order, this is the part that we need to actually, I need some more space here, you guys. Oh, and I can't erase this because I locked it down. Let me unlock it and erase it. Okay. I can't erase all of it. I can't get too close because then I'll erase the box with the problem. Okay, so I'm going to do it in a different color. So we have log 5 of x plus 8 over x plus 4. So we don't want the log 5 anymore. So to undo a log, you exponentiate. This is what I mean. If you have, this is another rule that we haven't talked about. Okay, do you know we had log 5 of 5 equals 1? See how they matched? Well, here's the cool thing too. 5 to the log 5 is equal to 1. It cancels out. So you can undo it, it equals 1. Okay, so when you're looking at here, the trick that we use is we use something called, we exponentiate. Exponentiate. What that means is we decide to raise everything from the 5th power. Forget that this is like kind of really big and obnoxious, okay? We are going to raise, I guess I should have put log 5 of x. Maybe, sorry. Let me switch this, you guys, just a little bit. Okay, log 5. Let's say you had this. That equals x is what I was trying to say. In other words, this is 1. The 5 log base 5 cancels each other out, and then you just get x. That's what I was trying to say. So, in other words, if we exponentiate it, look, all we did was change this to 5 to the log 5 x plus 8 x over x plus 4 equals 5 to the 1. Well, 5 to the 1 is 5. 5 to the first power is 5. These are going to cancel out, and you get x plus 8 over x plus 4. Then you have a proportion, or you just multiply by x plus 4 to get rid of the denominator. Okay. And, sorry, I'm going crooked here. Oh, man. Okay, these cancel, and you get, so sorry, I need to write smaller. 5x plus 20, right? 5x plus 20, and you're just solving for x now. You get 4x equals negative 12, correct? If I subtract 20, divide by 4, and you get x equals negative 3. And look, I know that seemed like a lot of work, but the trick is simply this little trick right here, okay? This is a good trick, okay? Taking the log, we'll learn how to do that in a second, but exponentiating is a cool little trick. You also, I want to show you something else. If you guys remember, your log rules, and you can deal with this wacko like answer here. Log 5 of x plus 8 over x plus 4, right? Equals 1. You could just change this to exponential form. That's always available to you. Base 5 to the first power equals x plus 8 over x plus 4. Do you see it? You have a choice. Okay, this feels more mathy and more like, I don't want to call it professional, but this feels a little bit easier. Like, okay, I just change it to exponential form and I've got it. Okay, remember that rule, log b of x, that whole thing. All right, let's try another one. Try to write a little neater this time. I apologize, that was pretty bad. So we have log 2 of x minus 5 equals 2 minus log 2 of x minus 8. So again, this number is a problem because we can't do anything with the logs. Dang it anyhow. But we can add this log to the other side so we can combine our logs together. So you get log 2 of x minus 5 plus log 2 of x minus 8 equals 2. Now you can use rule 1 to condense. Okay, we're going to condense it. So we're going to get log 2 of, and what do we do when we're adding exponents? It means we're multiplying the bases, okay? So x minus 5 times x minus 8. equals 2. Now, in this case, I'm just going to roll with the fact that we have this thing here. I'm going to change it to exponential form. Base to the exponent equals that. So 2 squared equals x minus 5 times x minus 8. So you get 4 equals x squared minus 8x minus 5x plus 40. Foiling that out, x squared minus 13x plus 40 equals 4. Okay, I'm actually doing this just pretty quick because it's just basic math here. Okay, you got a quadratic. What do you do to solve a quadratic? Set it equal to 0. So then we get x squared minus 13x plus 36, because we're subtracting 4, equals 0. Okay, so now what do you do to solve that? I'm going to rearrange it. Now you need to factor it. Okay, x and x, hopefully it's factorable. I think it is. It's 9 and 4, you guys. 9 and 4. 36 is 9. 9 times 4. So it's minus 9 minus 4. So x is equal to 9 or x is equal to 4. And that's your answer. Now you can go back and check it. You guys, you could literally plug it back in. I'm going to change colors. Okay, so you could go log 2 of, let's try 9. 9 minus 5 plus log 2 of 9 minus 8 equals 2. Does it? Let's check it out. Log 2 of 9 minus 5, which is 4, plus log 2 of 9 minus 8, which is 1. Does it equal 2? Does it? Well, what's log 2 of 1? 0. Remember, that's that rule. Log b of 1 is equal to 0. What's log 2 of 4? That means 2 to some power equals 4. So this is 2. 2 plus 0 equals 2. Check. See how cool it is? It's like, it seems like it's going to be so complicated, and it's not. Okay? Now, the question is, it says, if there is no solution, click on no solution. You actually have to check both answers. Okay? I'm going to check the other one now. I'm going to have to erase this. I'm not going to worry about erasing it because, you guys, this is a video. That means that you can write it down. And I don't have to worry about you not having it, okay? So if you didn't get it, obviously pause the video, rewind it. Okay, now let's check the 4, okay, because this is important. Okay, so we go log 2 of 4 minus 9, okay, plus, not minus 9. What am I doing? I plugged it into the wrong thing. Hello? Okay, log 2 of 4 minus 5. That's what it was, wasn't it? Yes, because here it is. I'm plugging it into here. Geez. Plus log 2 of 4 minus 8. Does that equal 2? Okay, let's try it. Log 2 of 4 minus, well, actually, we already did that. Duh. Okay, negative 1. Log 2, come on. Doesn't want to come up. Log 2 of negative 1 plus log 2 of negative 4. Does that equal 2? Okay, so let's think about this. This is saying 2 to some power equals negative 1. Is that possible, you guys? Okay, if you remember the log, it goes like this. This is the asymptote. We never get into the negative zone. This is not possible. You cannot get this negative number because no matter what, even if x is negative, right? All it does is move it to decimal, but you're never going to get a negative number. Okay, there's no negatives. So this is not possible. So you don't list this. If you list that 4, you'll get it wrong. So you have to go back and plug it in. Okay. All right, let's try the next one. And I'll try better. I'm trying hard, you guys. I'm just not succeeding. Writing it very pretty. I'm going to start over here. So we have log base 10 of 3 equals log base 10 of x minus 1 minus log base 10 of 4. Okay, so we got to take this in pieces. Okay, we don't have any numbers this time, but we do have logs. This one we're going to use rule 2 because it's a minus sign. So we're going to go log 3 equals, and then this minus sign means this part goes on the top, that goes on the bottom. So it's going to be log x minus 1 over 4. Okay, do you see how they're both logs? Okay, we can just equate these two answers. But just for the fun of it, I want to teach you how to get rid of the logs by exponentiating. You're going to exponentiate, put a 10 underneath. It's a cheat way to do it. Seriously, I just don't want to make you rewrite the whole dang thing. So we're going to exponentiate this. We are changing this to 10 to the log, it's base 10. See how they match? That undoes it, and you end up with just 3. This is base 10. These undo each other, and you end up with x minus 1 over 4. You multiply both sides by 4, and you're just doing your basic algebra here. Okay, x is equal to 13. And then you should plug it back in to make sure that it works. Okay, let's see. This one doesn't say if you don't have solution, all that other stuff. Okay, so here we go. We're going to go log base, log 10 of 3. I feel like we can't really plug this one in because we can't really figure these out in our head. I don't think this is a plug in a wonderful. I think you could plug it into a calculator, but you can't just figure it out by hand, unfortunately, without using the log rules, in other words, right? And I was trying not to use that. All right, let's try this one. Now it's ln. So don't worry about the ln bit. All you need to know about ln is that it means log, and the base is e. Okay? And that's how you write it. So there's a little invisible e here. Okay, sometimes I like to write it in just so that I can remember it's a base e. But it doesn't matter. We're going to use rule 1 because that's addition. Okay, and we're going to condense this. So the point of condensing it is to get logs, just one log on each side. The problem with the ones before, with the difference with the ones before, get back here. The difference with this one was that it had a number, and that made it hard. Okay. All right. So then you go, okay, ln e of x minus 1 times 3. I put it there just because I forgot to make room. Actually, if this were me doing the problem, I would totally change this. I'd be like, screw that. It's 3 times x minus 1. I like the number in the front. Okay, see how they're the same? So if we wanted to get rid of this log e, we would just exponentiate it. We would put a little e there. We would take e to the, and then you cancel these out, and you get x is equal to 3 times x minus 1. And then you continue on your merry little way and solve for x. I'm not going to do it to kind of make these notes a little bit shorter. Wait, am I going to get a negative number? Hang on. I guess I should, just in case we get a negative number. Negative 2x equals negative 1, negative 3. My bad. Distribute correctly. Negative 3. No, you get x equals 3/2, and that's okay because it's positive. If we had gotten a negative number, it wouldn't have been possible. Okay, did I start in the middle of this? I wonder if I started in the wrong spot. I'm losing my brain. Wow, I don't even know. Okay, again, look, it's log 10. You guys, we're going to use rule 2 to condense. So log of x minus 7 over 18 equals log of 6. Okay, now we have equated it. So you can exponentiate it, 10 to the, it'll cancel out both of these, and you can just set these equal to each other. You see how cool that is? That is how you undo a log. You exponentiate it. If you want to get rid of a log, you exponentiate it, but you have to do it to both sides, okay? It's not always so clean and neat. Okay, take a look at this one. Okay, this one says solving an exponential equation by finding common basis. Okay, take a look. Do you see how 81 is the base and 3 is the base? And they gave you a hint right here. Whenever you have a common base, there's a really cool little trick is you can move it, you can change it to the common base, and then you can just equate the exponents. In other words, if you have a to the m equals a to the n, then m equals n, correct? If they're equal, then the exponents must be equal. Okay, so if we change this 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th is, and then you would go times 4x minus 5, because it's still there. We didn't move it, equals 3 to the 12x. And now you can equate these and you can get rid of it. Okay, but I want to show you something just for the fun of it. Okay, so you can actually do this right here. Just to get this done with, let me do that. And then you would solve for x, okay? But I just want to show you the thought process. Remember I said, and I'll change colors so you know that this is just me doing some extra stuff for you guys, especially for you guys that are, like the logical explanation. Well, this is logical, but 3 to the 4 times 4 minus 4x minus 5 is equal to 3 to the 12x. Okay, what did I tell you? If you want to get rid of the exponent, what I meant by this is if you want to bring the exponent down, then take the log. I guess I should put it this way. If I said undo an exponent, but to undo an exponent, it means to bring it down. If you want to bring down the exponent. So there's many ways to solve it. I feel like when you kind of choose one. If you want to bring down the exponent, take the log. I feel like I avoided doing this and I would just do the easiest way possible, but I really like this. Check it out. I can now take the log 3 of both sides, because if I have log b of b to the x, oh man, is that what I messed up? Okay, this is the property I'm using. Log b of b to the x, because remember by rule 3, I can bring this down, and log b of b is equal to 1, remember? So that's why that's equal to x. So this is the trick. You take the log base 3 of both sides. So log base 3, and that undoes that. And then you bring everything down. Now, I really do think it was easier to just do it like this. Get the like bases. But isn't that cool? I just want you to know that. All right, this is teeny tiny. You guys, I am so sorry. I started in the middle. Why would I do that? Because I started on slide 5. Okay. I will just have to leave a note. My bad, you guys. Okay, so now we're going to do the easier problems. Well, why not? Why not? We just tackled the really hard problems. Why not do some easy problems? Okay, look at the difference between what we just did. We have log base 2 of negative 3x plus 1 equals 3. Notice the log is only on one side. Okay, so when the log is only on one side, you have a couple options. Okay, I'm going to show you what I think is the easy way for beginners, which is to change to exponential form. I think 80% of you are going to choose this way. Base to the exponent equals that. 2 cubed equals negative 3x plus 1. 8 equals negative 3x plus 1. And then solve it, right? You get 6 equals negative 3x. X is equal to negative 2. Okay? All right. So we found x, and you could plug it in. Negative 3 times negative 2 is positive 6. 6 plus 1 is 7. That's not right. 2 to the third is 8. 2 to the third. 2 to the third equals negative 3x plus 1. I subtracted 1. Oh, wait, I subtracted 1. And I got 7. I'm so stupid. 8 minus 1 is not 6. My bad, you guys. Okay. 8 minus 1 is 7. My bad. Yeah. But that's why you check it. Do you see? I love checking equations. I love checking equations because I know I'm always going to get it right. Okay. Or, I mean, I'm always going to be able to fix it, I should say. Okay. So you get negative 7/3 equals x. Okay. Then you can plug it in and you will see that if you do negative 7/3 times negative 3, you get positive 7 plus 1 is 8. And it checks. Trust me, 2 to the 3rd equals 8. All right. The other way to do it, and this is kind of like a more mathy way, I think it's kind of fun. It's kind of what I was just showing you. And that is to undo a log, exponentiate it. So you just do this. And that cancels this, and you get negative 3x plus 1 equals 8. Do you see how it's the exact same thing? Literally, it's the exact same thing. It's just different ways of thinking it. One is exponentiating the log to get rid of it, and one is changing it back to exponential form. All right, you guys, let me go ahead and enlarge this. Okay, here we go. This is log 2 of 3x minus 2 equals 4. So again, same thing. You can just change it to exponential form. 2 to the 4th equals 3x minus 2. And then solve. 2 to the 4th is 2 times 2 times 2 times 2, which is 16, equals 3x minus 2. 3x equals 18, right? Add x is equal to 6. All right, plug it in to check it. Make sure you're right, okay? You have log 2 of 3 times 6, we're going to plug in the 6, is 18 minus 2 equals 4. Log 2 of 16 equals 4, and this is a question mark. Is 2 to the 4th equal to 16? And the answer is yes. Okay. All right, the other way, log 2 of 3x minus 2 equals 4. To get rid of the log, you exponentiate. So we write a little 2 underneath here. Cancels out, and you get 3x minus 2 equals 16. 2 to the 4th is 16. Get it? Same problem. Pretty cool, right? Okay, next. Now what do? We got a 6 in the front of it, okay? So again, if you go back to solving your equations, you say things like my 3 questions I tell you all the time, which is, what do I want to get rid of? What's complicating this problem? Well, it gets really easy if we only had the log by itself. So boo, get rid of U6. It's not part of the whole log. You guys see this? This is really the log piece. That's the exponent chunk. That's just multiplying. So we can get rid of that by dividing it. And then you end up with log 4 of x plus 19 equals 2. And now you can change it to exponential form or exponentiate it, whichever is your pleasure. Okay, 4 to the 2. So 4 to the 2 equals x plus 19. And then solve. Okay, x is equal to negative 3. All right, plug it back in and you're good to go. All right, let's take a look at this one. This is actually the first problem type of the, wow, so sorry, I'm just not batting 100,000 today. Here we go. Okay, so we've got negative 8 plus log 2 of x plus 6 equals negative 5. Okay, well, here's my log. Now you could go, oh, negative 8, get your butt out of here. Okay, right? Because negative 8 is attached. It's okay, so we add 8 to both sides to get rid of it. Get rid of that. Bring it down. Log 2 of x plus 6 equals 3. So then 2 to the 3rd equals x plus 6. And again, I could have just exponentiated it. And I would have got the same thing. And don't forget, 2 to the 3rd is not 6, it's 8. Okay? And then, I'm sorry. Whoa. Oh, goodness, I started in the middle. I apologize. Maybe I'll have to actually explain that. All right, that's the end of this video.